Okay, so continuing on with our look at if statements. At this point, you may be wondering, hey, all of our if statements start with whether or not something is true, but sometimes we want to start with whether or not something is not the case, not equivalent, for example. Yes, if statements execute their immediate code block only if the statement within the parentheses being evaluated ends up being true, but it's perfectly logical to ask the compiler to execute that if-then code block if it's true that the statement is false, or if it's true that the operands are not equivalent. Now, the way I said that may sound weird, but this is actually very intuitive. We all reason like this naturally without even thinking about it. Let me illustrate by going back to where we started, but inverting the evaluation to look something like this. And actually, the first thing we should do is we'll make a whole new method definition, as we did before, to keep things nice and compact and clean. So, as before, we name it pretty much the same, but add a number after it. And here, we'll call it by adding that number, changing it to that method definition. So let's write in this code. If x is not equivalent to 100, I'm just going to put a comment there. Remember, comments, it's useful for more than just commenting out code. It's good for making notes for yourself, which you should be doing fairly frequently, especially as a beginner. If x is not equivalent to 100, output the debug log. X is not equivalent to 100. Surprise, surprise. And else, to catch the case that it is equivalent, we'll simply call the debug log and put in the argument x is equivalent to 100. All right, and save that. Go to our Unity console, run it. X is equivalent to 100. All right, so here we see the exclamation or exclamation mark operator, which is sometimes referred to by coders as bang in coding speak. But I don't really like saying bang, so I'll just stick to saying exclamation. So it can be read simply as not. And you notice we drop the second equal sign when you pair it with the equal sign and create the not equivalent operator. So I'm not really sure why they chose to drop the second equal sign. It's pretty commonly represented like this in coding. It's a bit confusing, but here this is just the combined operator of not and equivalence, which gives us not equivalent. Just remember that and you'll get used to it. So is it true that x, in this case, is not equivalent to 100? No, of course not. So what happens is it drops down to the else statement. We get the same basic logic output. It's just inverted now. So one interesting thing about the exclamation operator is it can be added to the binary operator, as we did here, the equivalence operator, which is binary because it checks for equivalence between two operands, right? Remember how I mentioned operands, the elements being evaluated on each side of the operator. But the exclamation operator has an added functionality in that it can be also used on a single operand, making it also a unary operator. So binary when it's operating on two operands, unary as in uno as in one when it operates on a single operator. So you can add it to an entire statement even, or a bool having the effect of flipping its value, right? So let me show you how you do this, how you would add it to an entire statement in your conditional evaluation. So let's go here and write in, instead of saying is x not equivalent to 100, we'll basically move it to the entire statement. So we'll wrap this statement, sorry, not 3 equal signs, 2 equal signs. So we'll wrap the statement into parentheses. So we'll evaluate that, and then we'll put the bang, sorry, exclamation operator at the front of that entire statement. So read out, this statement would be something like, if it's true that it's not the case that x is equivalent to 100, then do this. All right. This is kind of horrible for readability. So, you know, it's not something I'd recommend you do. I don't see it being used in this way very often, but it does make logical sense. If something is true that it's not true, it's ultimately false, right? So in the end, don't worry about seeing code as confusing as this. I just wanted you to see the versatility of the exclamation mark, the not operator, and ultimately use it for readability, where it makes more sense to check for something being not the case first. We can also use the exclamation as a unary operator, as I mentioned, on bools. Remember bools? We just saw it a couple of videos back. Bools have true and false built right into them. So we can easily evaluate them as follows. So let's comment out. Actually, let's just make another method definition. For bools, and call that new one now. So let's write in this bool val equals true if val output to the debug log val is true, else val is false. Save that. I'm sure you can guess what you're going to see next. Val is true, of course. So this is the same here. What we're doing here is we're evaluating val as true or false, and it's saying if val is true, then do this immediate code block, else fall to the else clause. All right, so this is exactly the same as doing if val is equivalent to true. And you can write that. That's perfectly legal and does exactly the same thing. But it's just a little bit cleaner to just type in the bool and check if it's true. That's all that means. So we can use the exclamation as a unary operator on this, and we'll first check if it's not true that it's true, which means it'll only evaluate true if it's false. You know, you'll get used to that kind of way of thinking. It may seem kind of strange when you say it out loud, but it's actually pretty intuitive. Val is false. All right, this evaluation evaluated correctly, but we kind of made it confusing. We should flip these now to get the actual correct message that we're anticipating. There we go. That's actually what we're expecting. All right. So in this case, what we're doing is we're evaluating if val is not true. That's what the exclamation mark in front of the bool is representing when it's in that if statement evaluation. It will always be represented that way. But as if that wasn't enough, exclamations are versatile even more in that they can perform an operation on the bool itself and store that result. So for example, you can do this. Let's just comment this out. And let's write in val equals not val. So what do you think is going to happen We're performing an operation on val now. And let's put in our debug log. What do you think is going to happen now that we put this exclamation mark in front of val, which is true, making it not val, whatever value val has at that moment, and then assign it back to val. Right? Let's run it. See if you guessed right. False. So the operation here is take whatever value, whether it's true or false, that val currently holds, and make it not that. In other words, the opposite of that value. So this can be very useful in programming, or any programming where you want a simple toggle switch. You can just keep toggling back and forth. So let's do something like this to illustrate that in action. Actually, what I'll do is I'll just copy and paste this, because it's going to be exactly the same. And if you're understanding what this is doing correctly, try to anticipate the output here. All right? I'm just going to save it and run it, and let's see if you anticipated it correctly. It's going to output every time it flips. It first flips from true to false, then it flips to true, and then it flips to false again. See, that's the switching that I was talking about. Starts off as true, then it flips it, not true, stores it back, that would be false, and then it flips false back to true, stores that, we get true, and then it takes the true finally again, flips it back to false, stores it, and we finally get false. So now, with that, I showed you some fairly basic examples of if statements in action, but there will often be a case where you'll want to evaluate a bunch of different things. So remember when I showed you how to create your own order of operations by using parentheses in math operations? Well, here again, we'll see their use in creating more complex conditional statement clauses. So let's write some more code. Let's create another. Another method definition for this. All right. So right in this, what we're going to do is we're going to simulate a button being pressed, because right now we're not actually using the Unity input mechanism to register button presses. So we'll just simulate it that a button is being pressed. So I'm going to put a comment here. Simulating button presses, just so we remember what it is we're doing. Type in bool is button A pressed, arbitrarily named, true, set it to true. Then bool is button B pressed, set that also to true. And then let's make a little conditional to evaluate this state. So if is button A pressed, and that stands for and is button B pressed. So if both of these buttons that we're simulating are being pressed, we'll output to the debug log our button conditional evaluates as true. And I'm going to copy that to go a little quicker, else, and then same thing, but it evaluates as false. We'll save that and run it. So both buttons are simulated as being true, which is that they're being pressed. So it executes conditional. The button conditional evaluates as true. It executes the first if clause because the entire statement evaluates as true if and only if both of these are true. If we make one false, doesn't matter which one, they could be both false or one of them false, and then this conditional will not evaluate as true any longer. There you go. Evaluates as false. So this is a very handy functionality that we'll be using a lot. Actually, we'll be using it often with button presses. And you don't have only and available to you. You also have or, which is another common logical operator. So to represent or, we will type in the pipes operator, or turnstile, I've sometimes heard it being referred to as, which is the shift and, on my keyboard, the shift and backslash key, which gives you that straight line. So you just type in two of those and you get the or operator. So button A pressed is true, button B pressed is false. What do you think this is going to evaluate as? Right? Well, all it requires is that one of these is true or the other one is true. It could be both, but all it requires is one. So which one do you think it should output? Let's save it and run it. Yes, of course. It evaluates as true because it is true that one or the other is true. In this case, is button A pressed is true. All right.